Hi, my name's Corinne, and today for the video I've decided to talk about lipids. Lipids are fat that are found with varying structure and function. These fats are found in butter and olive oil in the form of triglycerides. Here I have a picture of the structure of traditional triglyceride. Each triglyceride consists of 3 fatty acid chain tails attached to one molecule of glycerol. When we consume these lipids, our bodies possess lipases, which allow us to break down these triglycerides. When these enzymes function in this breakdown, our bodies receive energy from the fatty acid tails because they were storing energy. The actual energy is due to the fact that the fatty acid tails have a hydrocarbon configuration. This means that the energy is due to the fact that the fatty acid tails are made up of hydrogen and carbon atoms. The bonds between these hydrogens and carbons are what actually provide the energy. In both butter and olive oil, the fatty acid tails of the triglyceride have this hydrocarbon composition. However, the structure of these hydrocarbon tails is what makes butter and olive oil differ from one another. In butter, the triglycerides are saturated. What this means is that its tails not only possess hydrogen and carbon atoms, but they possess these in a configuration of only having single bonds. This pertains to the tails being saturated with hydrogen. When this occurs, the tails are able to pack tightly with other saturated tails and are more likely to be solid at room temperature. This is why the butter I have here is solid. Now, if we look at the olive oil, we can see that it is not nearly as solid as the butter. The reason why olive oil is liquid at room temperature instead of solid is because its tails are unsaturated. This means that its tails possess not only single bonds, but double bonds as well. These double bonds can be either cis or trans conformation. These words pertain to the location of the hydrogens that are involved in the carbons making the double bond. If the hydrogens are on the same side as one another, the cis conformation results. However, if they are on opposite sides of one another, trans conformation exists. Trans conformation unsaturated fatty acids are extremely harsh on our bodies. But no matter which conformation arises, the tails of these unsaturated fats are bent. Because of this kinky conformation, these tails are not able to pack as tightly as the tails of saturated fats. This results in the typical liquid conformation at room temperature of olive oil. Therefore, even though butter and olive oil both have hydrocarbon tails, meaning they're composed of hydrogen and carbon, the conformation of these tails leads to different characteristics between these two fats. Before I go on to my recipe, I wanted to show a quick example that demonstrates the difference in the types of packing between butter and olive oil. I didn't have any molecular model, so instead I decided to use regular white printer paper. First, I'll demonstrate the packing between saturated hydrocarbon chain tails. Another word to describe these tails is to call them straight chains. This describes the fact that they don't have any kinks because they only have single bonds. We can relate this to a flat piece of paper. The increasing overall thickness, as I stack these on top of each other, is minimal. We can see how this stacking shows very tight packing if these were fatty acid chain tails. We can look from all angles and see that the increase in thickness is minimal. On the other hand, if we stack the kinky tails, which indicates the chain of unsaturated fats, this leads to much less tight packing between the tails, which we can see here by a larger increase in the overall thickness, especially if we compare this to the saturated fats, which indicate the plain white paper. So, you can definitely tell the overall thickness in these packing abilities leads to the different overall thickness. Now the recipe that I've decided to use today is a traditional rice recipe. Yellow Mexican rice because it's my favorite. I love Vigo. But even though butter and olive oil, as you can see here, are in different phases of matter, they're both fats and therefore can both be used when making this rice recipe. The purpose of choosing to incorporate a fat when cooking rice is because it improves the texture while adding flavor and moisture. This moisture is helpful so that your rice doesn't stick to your pan or become burnt. Because butter and olive oil are both fats with hydrocarbon composition, they can be substituted for one another in this case. Due to the tight packing of saturated fats, they are the least healthy fats for our bodies, and therefore many people choose to substitute butter with olive oil, because the unsaturated fats are easier on our bodies. However, in cooking rice, you should observe the same result in the composition of your finished rice product, whether you use butter or olive oil. So, both of these pans, one's a little bit smaller than the other, but they have the same amount of water for our rice recipe. In the first pan, I will add olive oil, and in the second pan, I will add butter. The recipe calls for 2 tablespoons of olive oil. I have a half teaspoon measure, so I'll add this 4 times, equal the total 2 tablespoons. Now that I've completed that, I will add the butter to our second pan. The recipe also calls for 2 tablespoons of butter. I will add this to my second pan. And the first instruction is to bring these to a boil. So I'll remove this from the area, and I'll bring the component of both of these pans to a boil. Once these were brought to a boil, I added the rice mixture to both pans and turn the heat to low, and I will let them cook until they are finished. The rice is now finished, and now that I've finished cooking the rice, we can see that the rice cooked with the butter and the rice cooked with the olive oil are both non-sticky, and they both have and you can tell they have the same the same texture. So this just shows that olive oil can be a very good substitute for butter. Both of the rice cooked to their proper texture, just how they should have. The hydrocarbon composition of both of these fats allowed for this substitution. So once again, if we look at these rices here in these bowls, we can tell that either using olive oil or butter, they're both a good common substitution for one another when cooking rice. But don't forget to keep in mind that butter or olive oil may not always be as easily substituted in other recipes. For example, if you are specifically looking for that buttery flavor in baked goods such as pound cake, shortbread, or croissants, you want to stick with butter. This is also true if you're making candy where you want that creamy flavor. A time when olive oil may be desired is if you're trying to eat healthier or you want to fry something. Olive oil has a higher burn point than butter. Olive oil's burn point is around 410 degrees Fahrenheit, while butter's burn point is around 300 degrees Fahrenheit. Therefore, you can use a higher temperature when frying if you use olive oil. Well, that's it for today. I'm going to go enjoy some rice now. Thanks for watching.